Okay, if we can go one direction, we can go the other. There's a good One Direction joke in there somewhere. Just not sure what it is. Okay, so you should be able to take anything that has a radical or a rational exponent and rewrite it as a radical. So your base is going to become your radicand. Then you're going to have your radical. And where you put everything, then again, depends if you understand where the two pieces of the fraction go. Remember, your denominator was always your index, so it would go right here. Now, we never write the square root, it's always assumed to be there. So if your denominator is a 2, it's a square root. You don't need to write it, you probably shouldn't write it, because you're never going to see an actual square there. Again, the root itself indicates a square root. And then you have the 1. Now in this particular problem, we could put the 1 here. You could put the 1 on the outside. But even more importantly, which I think you probably already recognize, is you don't really need the 1 at all in this case. It doesn't impact the problem at all. So the square root of 17 and 17 to the 1/2 power are the exact same thing. So then, what am I going to do with 9 to the negative 5/2 power? I'm going to make sure I get rid of that negative exponent right away, so therefore I don't have to worry about dealing with it. Remember what that means. We take the whole fraction, base and the thing with the negative exponent all move to the bottom. That 1 now is on the top. There's always a 1 left behind, so if everything clears out of a room, 1's still lingering there. And now the 9 and the exponent become positive. So now the rest of your problem will continue on with the 9 on the bottom in a fraction. So again, we have our 9, we put our radical, our denominator becomes our index. Again, in this case, again, because of the fact that it's a 2, don't do anything with it. And then the 5, you have your choice. You can put the 5 here, or I could put the 5 here. Now, either one is correct, except unless, of course, you don't realize that you can go a little bit further with this problem. And if you recognize that you can go a little bit further with this problem, then this particular version actually is going to make life a little bit easier. In this case, if we follow the correct order of operations, this tells me I should take the square root of 9 first, and then raise it to the 5th power. Whereas the other example would expect me to take the 9 to the 5th power first, and then take the square root. This is way easier to evaluate. And 3 to the 5th power, easy enough in our calculator, is 243. That should be your next answer. All right, the next two are rather involved. Again, I suggest that you just pause the video, try them out on your own, and then come back and see if you did them correctly. Okay, with problems like these, you've got a lot of options. And some options, though not completely incorrect or incorrect at all, actually might not cause you to get a nice answer. So one of the options is you could take this 2/3 and you could distribute him. And then you end up with something that looks like 27 to the 2/3, x to the 10/3, and y to the 2/3. Now, okay, but that doesn't also help you rewrite this in radical form, and now you've got 3 different sets of bases with exponents that are fractions versus just 1. So hopefully you went with the other option, which was to keep that 27, x to the 5th, and the y, put it underneath the radical. The 3 becomes your index. Then you've got that square. In this particular case, unlike the last example, I think keeping the square inside actually might be a little bit more useful. Maybe keeping it on the outside would be more useful. But I'm going to go with this since this is the way that seems to make more sense to me. So I'm going to take everybody and inside that's in this parentheses, and I'm going to make sure everybody gets squared. Yes, including the 27. And that becomes x to the 10th, y to the 2nd. And now what's going to happen, take us back to a couple days ago, is we're going to simplify this cube root with our perfects and our leftovers. So somewhere off to the side, I'm going to have to work on that 729. and I'm going to assume that that's what you've done. 729 starts dividing by 3, and you're just going to keep going. So 729 is perfect, and that's 3 cubed, 3 cubed. X to the 10th is not a perfect cube, but x to the 9th is, with 1 left over. And y squared, certainly not a perfect cube, so it's all your leftovers. Evaluate these little guys here. That's going to cause that cube and cube root to cancel out, cause that one to cancel out. That's going to leave you with 9. Your x to the 9th, we divide that 9 by 3, x cubed, and then you've got xy squared. Fun stuff. Alright, this little guy. Alright. I'm going to take him and first get rid of the negative exponent here. Okay. Then maybe I'm going to try this. And this could completely fall flat for me. I have no idea actually yet. Let's just take it and see where it goes. If I make a mess of it, I'm going to just try a different route. I'm going to keep that 6. I'm going to keep that c to the negative 9th, d to the 12th. Do I want the 5 on the inside or the outside? I think I'm going to keep it on the inside. That's going to allow me to distribute it to everybody underneath that radical, and then maybe I can find that perfect 6th root. So that 1 in the top kind of has to stay there. We need him. Keep this as a 6th root. And that becomes c to the negative 45th and d to the 60th. Okay, can't leave that negative exponent, so I'm going to put that as the 6th root of d 60 over c to the 45th. Okay. Now we're just going to kind of see where this goes. I'm going to take it to the next page. Alright. Keep my 1. It's the easiest part. And we're going to split this up into 2 radicals. My top part goes pretty nicely because 60 is divisible by 6, so that's a perfect 6th root. So that's going to become d to the 10th. This isn't as simple because of the fact that 45, c to the 42nd is a perfect 6th, but c to the 3rd would have to be left over. And so 42 divided by that 6 gives you c to the 7th, 6th root of c cubed. Now, this is ridiculously ugly, and you're probably, looking at the screen and listening to this and complaining, and I wouldn't blame you because the first 2 were really easy examples, and then these last 2 were really crazy examples. The good news is when we come into class next time, we're just going to practice these in class. So we're just going to do lots and lots of practice, less instruction, because you're kind of looking at it now. This answer is not terrible, but fractions within fractions, not the best thing in the world. So we've actually got this little guy here is 1 divided by this d to the 10th over c to the 7th, 6th root, c to the 3rd. And remember that in order to actually divide, you're doing the same as multiplying by something's reciprocal. So technically our final answer should be c to the 7th, 6th root of c squared, all over d to the 10th. And if you got anywhere close to that, I'm impressed.